Gildan Media, a division of Recorded Books, presents The Biological Mind: How Brain, Body, and Environment Collaborate to Make Us Who We Are, by Alan Jasanoff. Narrated by Paul Boehmer. Introduction. What makes you, you? Wherever you come from and whatever you believe about yourself, chances are that, to some extent, you know your brain is the heart of the matter. Although it is said that there are no atheists in foxholes, there are also few people who will not duck when the shooting starts. Nobody wants a bullet in their brain. If you trip and fall forward on a concrete sidewalk, your arms rise instinctively to protect your head. If you are a cyclist, the only protective gear you probably wear is your helmet. You know something important is under there, and you will do what it takes to keep it safe. Your concern for your brain probably does not end there. If you are smart or successful, you pride yourself on your brain power. If you are an athlete, you prize your coordination and stamina. Likewise, products, at least in part, of your brain. If you are a parent, you worry about your child's brain health, development, and training. If you are a grandparent, you may worry about your own aging brain and the consequences of brain atrophy. If you had to swap body parts with someone else, your brain would probably be the last part you would consider exchanging. You identify with your brain. How complete should this identification be? Is it possible that everything truly significant about you is in your brain, that, in effect, you are your brain? A famous philosophical thought experiment asks you to consider just this possibility. In the experiment, you imagine that an evil genius has secretly removed the brain from your body and placed it in a vat of chemicals that keeps it alive. The brain's loose ends are connected to a computer that simulates your experiences as if everything were normal. Although this scenario seems like nothing more than science fiction, serious scholars use it to consider the possibility that the things you perceive may not, in fact, represent an objective reality outside your brain. Regardless of the outcome, the premise of the thought experiment itself is that being a brain in a vat violates no physical principles, and that it is at least theoretically conceivable. If scientific advances eventually made it possible to maintain your disembodied brain, the scenario implies that the irreducible you would indeed be in there. For some, the idea that people can be reduced to their brains sounds a powerful call to action. A young woman named Kim Susie heard that call. At just 23 years old, Susie was dying of cancer, but she refused to go gentle into that good night. She and her boyfriend decided to raise $80,000 in order to fund the preservation of her brain after she died. Susie believed that technology might one day enable her to be brought back to life, either physically or digitally, through structural analysis of her frozen organ. Science is nowhere near up to the task right now, but that did not deter her. To Susie, in her final days, the brain became everything. Others have taken Susie's path as well. I myself have had a related experience, which I will describe later in this book. When we are confronted with mounting evidence that the brain is central to all we once associated with ourselves, our spirits, and our souls, it is not surprising that some of us react dramatically. In our brave new neuroscientifically informed world, the brain bears the legacy of several millennia of existential angst. Our ultimate hopes and fears can come to revolve around this organ, and in it we may seek answers to eternal questions about life and death. virtue and sin, justice and punishment. There is no mental function for which researchers have not succeeded in finding corresponding activity patterns in the brain, using either imaging techniques in people or more invasive measurements in animals. We see brain data increasingly entering courtrooms, the risk of brain injury newly affecting our pastimes, and brain-targeted medicines prescribed to alter a gamut of behavior from school performance to social graces. A lesson from the legendary Greek philosopher Hippocrates is penetrating the public consciousness. Men ought to know that from nothing else but your brain come joys, delights, laughter and sports, and sorrows, griefs, despondency, and lamentations. Everything important about us seems to boil down to our brains. This is a stark claim, and my aim in this book is to show that it sends us in the wrong direction by masking the true nature of our biological minds. I argue that the perception that the brain is all that matters arises from a false idealization of this organ and its singular significance, a phenomenon I call the cerebral mystique. This mystique protects age-old conceptions about the differences between mind and body, free will, and the nature of human individuality. It is expressed in multiple forms, ranging from ubiquitous depictions of supernatural, ultra-sophisticated brains in fiction and media, to more sober scientifically supported conceptions of cognitive function that emphasize inorganic qualities or confine mental processes within neural structures. Idealization of the brain infects lay people and scientists alike, including myself, and it is compatible with both spiritual and materialistic worldviews. A positive consequence of the cerebral mystique is that exalting the brain can help drive public interest in neurobiological research, a tremendous and worthy goal. On the other hand, the apotheosis of the brain ironically obscures consequences of the most fundamental discovery of neuroscience, that our minds are biologically based, rooted in banal physiological processes, and subject to all the laws of nature. By mythologizing the brain, we divorce it from the body and the environment, and we lose sight of the interdependent nature of our world. These are the problems I want to address. In the first part of this book, I will describe the cerebral mystique as it exists today. I will do this by considering themes in today's neuroscience and its public interpretation that underemphasize the brain's organic, integrated characteristics. I argue that these themes promote a brain-body distinction that recapitulates the well-known mind-body dualism that dominated Western philosophy and religion for hundreds of years. By perceiving virtual barriers between our brains and our bodies, and by extension, between our brains and the rest of the world, we see people as more independent and self-motivated than they truly are, and we minimize the connections that bind us to each other and to the environment around us. The disconnected brain acts as a stand-in for the ethereal soul, inspiring people like Kim Susie to preserve their brains upon death in the hope of attaining a form of immortality. In upholding the brain-body distinction, the cerebral mystique also contributes to chauvinistic attitudes about our brains, minds, and selves, such as the egotism of successful leaders and professionals and the us versus them attitudes of war and politics. In the individual chapters of Part 1, I will introduce 5 specific themes that give rise to the brain-body distinction and that tend to elevate the brain above the rest of the natural realm. By scrolling through alternative, scientifically grounded perspectives, I will try to bring the brain back down to earth. The first theme I will address is abstraction, a tendency for people to view the brain as an abiotic machine, based on fundamentally different principles from other living entities. This is best exemplified by the familiar analogy of the brain to a computer, a solid-state device that can be perfected and propagated in ways that evoke a disembodied spirit. The second theme is complexification, a vision of the brain as so vastly complicated as to defy analysis or understanding. The inscrutably complex brain is a convenient hiding place for mental capabilities we want to possess but cannot explain, like free will. The third theme is compartmentalization, a view that stresses the localization of cognitive functions without offering deeper explanations. Supported largely by the kinds of brain imaging studies we often see in the media, the compartmentalized view often facilitates shallow interpretations of how the brain helps us think and act. The fourth theme is bodily isolation, a tendency to see the brain as piloting the body on its own, with minimal influence from biological processes outside the skull. The fifth and final theme is autonomy, the view of the brain as self-governing, receptive to the environment, but always in control. These last two themes allow us to see ourselves as cut off from impersonal driving forces both inside and outside our bodies that nevertheless dramatically affect our behavior. In Part 2, I will explain why a more biologically realistic view of our brains and minds is important, and how it could improve our world. I consider three areas that today are heavily influenced by the cerebral mystique: psychology, medicine, and technology. In psychology, the mystique fosters a view that the brain is the prime mover of our thoughts and actions. As we seek to understand human conduct, we often think first of brain-related causes and pay less attention to factors outside our head. This leads us to overemphasize the role of individuals and underemphasize the role of contexts in a range of cultural phenomena, from criminal justice to creative innovation. An updated view that moves beyond idealizations must accept that the body's physiological milieu, encompassing but not bounded by the brain, provides an unequivocal meeting point for influences, both internal and external, to every person. Our brains, seen in this way, are complex relay points for innumerable inputs, rather than command centers endowed with true self-determination. Whenever I have an idea, my idea is the product of all of these inputs converging at once around my head, rather than mine alone. When I steal or kill, whatever happens in my criminal brain is the product of my physiology and environment, my history, and my society, including you. In medicine, a grave consequence of the cerebral mystique is to perpetuate the stigma of psychiatric disease. Accepting that our minds have a physical basis relieves us of the traditional tendency to view mental illness as moral failings. But recasting psychiatric conditions as brain disorders can be almost as damning to the patients affected. Society tends to view broken brains as less curable than moral flaws, and people thought to have problems with their brains can be subject to greater suspicion as a result. Equating mental disorders with brain dysfunction also skews the treatments people seek, leading to greater reliance on medications and less interest in behavioral interventions such as talk therapy. And seeing mental illness purely as brain disease overlooks an even deeper issue: the fact that mental pathologies themselves are often subjectively defined and culturally relative. We cannot properly grapple with these complexities if we reduce the problems of the mind to problems of the brain alone. For some people, the cerebral mystique inspires technological visions for the future. Many of these revolve around science fiction and the idea of hacking the brain to improve intelligence, or even eventually upload our minds and preserve them for eternity. But the reality of brain hacking is less glamorous than its image. Invasive brain procedures have historically incurred high risk of injury and helped only the most debilitated patients. The neurotechnological innovations that meet society's needs might best remain outside our heads. Indeed, such peripheral tech is already turning us into transhumans, armed with portable and wearable electronics. Both hopes and fears about neurotechnology are distorted by artificial distinctions between improvements that work directly and those that work indirectly on our central nervous systems. By demystifying the brain, we will be better able to enhance our lives while solving the scientific and ethical challenges that arise along the way. Before getting into my argument, I want to say a few words about what this book does not try to do. First, it does not explain how the brain works. Unlike many other authors, I am concerned more with what the brain is than what it does. Although several of my chapters include examples of specific brain mechanisms, my purpose in introducing them is largely to illustrate modes of action that depart from widespread stereotypes about the brain. Just as many artists strive to give emotional and psychological depth to flat figures from history and legend, I hope, in a humble way, to add dimensionality and nuance to an organ that popular writing often depicts as a dry computing machine rather than a thing of flesh and blood. Second, this book does not challenge the fact that the brain is essential to human behavior. Functions of the mind all require the brain, even if they do not reduce to the brain. Many of these functions are almost as poorly understood now as they were 50 or 100 years ago, and basic neuroscientific explorations of phenomena such as memory, perception, language, and consciousness are the best way to advance our knowledge. I will illustrate how traditional ways of looking at the brain can be complemented by alternative and broadened views. But neuroscience and the brain remain at the center of the picture. Third, and most important, this book in no way aims to reject objective neurobiological findings. The perspectives I offer will foster a view of our minds and selves as more interconnected than old-age culture traditionally views them. But this is no invitation to slip into ungrounded New Age spirituality. It is hard scientific research itself that paints a picture of the brain as biologically grounded and integrated into our bodies and environments. Conversely, it is the cerebral mystique and its emphasis on the extraordinary features of brains that drive people to doubt the power of science to illuminate human thought and behavior, a view that I, like most neuroscientists, emphatically reject. The cerebral mystique limits the impact of neuroscience in society today by presenting the brain as a self-contained embodiment of the mind or soul. This view makes it easier to black box the nervous system, to treat what happens in the brain as confined to the brain, and to ignore what neuroscience might have to say about real-world problems. This is a view I mean to set aside, and I hope that this book will convince you to agree. Part 1. The Cerebral Mystique. 1. Eating the Brain. When I first touched a brain, it was braised and enveloped in a blanket of beaten eggs. That brain had started its life in the head of a calf, but ended in my mouth, accompanied by some potatoes and a beverage at an economical eatery in Seville. Seville is a Spanish city, famous for its tapas, and tortilla de sesos, as well as other brain preparations, are occasional offerings. On my brain-eating trip to Seville, I was too poor to afford sophisticated gastronomic experiences. Indeed, some of my most vivid recollections of the trip included scrounging around supermarkets for rather less satisfying food, while the delectable tapas remained out of reach, only for the ogling. The brain omelette was certainly one of the better meals I had. My next encounter with sesos came many years later in a laboratory at MIT, in a crash course on neuroanatomy, whose highlight was certainly the handling and dissection of a real sheep's brain. At that time, I was drawn to the class and to the sheep's brain by a diffuse set of concerns that motivate many of my fellow humans to follow and even embed themselves in neuroscience. The brain is the seat of the soul, the mechanism of the mind. I thought by studying it, we can learn the secrets of cognition, perception, and motivation. Above all, we can gain an understanding of ourselves. The experience of handling a brain can be awesome, in the classical sense of the word. Is this lump of putty really the control center of a highly developed organism? Is this where the magic happens? Animals have had brains or brain-like structures for nearly 500 million years. Over 80% of that time, the ancestors of sheep were also our ancestors, and their brains were one and the same. Reflecting that extensive shared heritage, the shape, color, and texture of the sheep's brain are quite like our own, and it is not hard to imagine that the sheep's brain is endowed with transcendent capabilities analogous to ours. The internal complexity of the sheep's organ is indeed almost as astounding as that of the human brain, with its billions of cells, trillions of connections between cells, and ability to learn and coordinate flexible behaviors that carry us across lifespans more convoluted than the cerebral cortex. The sheep's brain bears witness to years of ovine toil, longing, passion, and caprice that are easily anthropomorphized. And that brain, removed from the rest of its body and everything the ex-sheep once felt or knew, is as powerful a memento mori as one can find. But the sheep's brain, like ours, is also a material highly similar to other biological tissues and organs. Live brains have a jelly-like consistency that can be characterized by a quantity called an elastic modulus, a measure of its capacity to jiggle without losing its form. The human brain has an elastic modulus of about 0.5 to 1.0 kilopascal kPa, similar to that of Jello, 1 kPa, but much lower than biological substances such as muscle or bone. Brains can also be characterized by their density. Like many other biological materials, the density of brains is close to water. Given its size, an adult human brain, therefore, weighs about as much as a large eggplant. A typical brain is roughly 80% water, 10% fat, and 10% protein by weight, leaner than many meats. A quarter pound of beef contains 180% of the U.S. recommended daily value of vitamin B12, 20% of the niacin and vitamin C, 16% of the iron and copper, 41% of the phosphorus, and over 1,000% of the cholesterol, a profile somewhat resembling an egg yolk. Risk of clogged arteries aside, why not eat the brain rather than study it. About 2 million years ago, near what is now the southeastern shore of Lake Victoria, in Kenya, ancient hominins were doing just that. Lake Victoria itself, the largest in Africa and source of the White Nile, is less than 500,000 years old, and was then not even a glimmer in the eye of Mother Nature. Instead, the area was an expansive prairie roamed by our foraging forebears, who subsisted on grassland plants and the flesh of prehistoric grazing animals that shared the terrain. Archaeological findings at this site, known as Kanjara South, document the accumulation of small and mid-size animal skulls at specific locations over several thousand years. The number of skulls recovered, particularly from larger animals, substantially exceeds the corresponding number of other bones. This indicates that animal heads were separated from the rest of their carcasses and preferentially gathered at each site. Some skulls bear the marks of human tool use, thought to reflect efforts to break open the cranial cavities and consume their contents. Brains were apparently an important part of the diet of these early people. Why brains? In evolutionary terms, the Kanjara humans were relatively new to meat-eating. Carnivory in Homo is documented as beginning only at about 2.5 million years ago, Maya, though it is believed to have been a major factor in our subsequent development as a species. Non-human carnivorous families on the scene at 2 Maya had been established meat-eaters for many millions of years already. The biting jaws and catching claws of the great Pleistocene cats, the giant hyenas, and the ancestral wild dogs were better adapted to slaying, flaying, and devouring their prey than anything in the contemporary hominin body plan. But early humans had advantages of their own. Already the bipedal stance, the storied opposable thumb, and a nascent ability to form and apply artificial implements all conferred special benefits. If a primordial person stumbled across the carcass of a slain deer, pungent and already picked to the bone by tigers, she could raise a stone, bring it crashing down on the cranium, and break into a reservoir of unmolested edible matter. Or, if she brought down an animal herself, she could pry off the head and carry it back for sharing with her clan, even if the rest of the animal was too heavy to drag. In such fashion, the hominins demonstrated their ability to carve out an ecological niche inaccessible to quadrupedal hunters. Although other carnivores competed vigorously with humans for most cuts of meat, brains may have been uniquely humankind's for the taking. Synchronicity on a geological time scale may explain the coincidence of early hominin brain-eating and the emergence of massive, powerful brains in our genus. But the two phenomena are connected in other ways as well. Highly evolved human civilizations and their corresponding cuisines across the world have produced edible brain preparations that range from simple, everyday dishes to splendid delicacies. Celebrity chef Mario Batali brings us calf-brain ravioli straight from his grandmother, needing about 1 hour of preparation and cooking time. Traditional forms of the hearty Mexican hominy stew, called pozole, are somewhat more involved. An entire pig's head is boiled for about 6 hours until the meat falls off the bone. Unkosher, but perhaps appetizing all the same. Truly festive brain dishes are prepared across much of the Muslim world on the Feast of Sacrifice, Eid al-Adha, which celebrates Abraham's offering of his son, Ishmael, to God. These recipes, brain masala, brains in preserved lemon sauce, steamed lamb's head, and others, leverage the glut of ritually slaughtered animals generated on the holiday, as well as a cultural reluctance to let good food go to waste. Who could forget the highlight of Indiana Jones's Himalayan banquet on the threshold of the Temple of Doom? A dessert of chilled brains cheer.
Sample complete. Ready to continue?